Hello everyone and welcome back to Aviatrix Deep Dive with Saad. In this session I'll be discussing about the hybrid connectivity for OCI. Like any other cloud, you have two options using either the private circuits or the public circuits. In private circuits there are different ways, and same thing with the public circuit, which I'll be discussing in this particular session. Like GCP, Azure, and AWS, there is no way you can get the on-prem or a hybrid cloud connectivity to the OCI environment without the end-to-end encryption. So we will start with the private circuits and with a standard end-to-end encryption first. All right, so let's first discuss the private circuits. Private circuit in OCI world is called the Fast Connect. So here, I'm going to draw the Aviatrix transit architecture with Aviatrix spoke VCNs on top. These are the spokes. And here we have spoke gateways. These are Aviatrix spoke gateways. We do have transit VCN. In transit VCN, we have transit gateways, and we are going to attach the transit gateways to the spoke gateways. I'm showing one connection. Basically, every VCN, we will see like 4 active mesh connections to the transit VCN. In order for you to use the Fast Connect, which is the private circuit of the OCI, you have to use another native construct called a DRG. It's similar to the transit gateway of AWS. This is the WAN router in the on-prem world, and then you are going to attach the transit VCN. So this becomes your transit VCN to the DRG. Once you attach the transit VCN to the DRG, DRG knows about the subnets of the transit VCN, and it's going to advertise it over to the on-prem WAN router. The on-prem WAN router is going to have the BGP with the DRG, and it's going to advertise its connected interfaces to the DRG. And now what you need at this point, you need to create a routing table over here, a new routing table, and attach that routing table to the DRG. So what's going to happen, that the BGP learned routes in the DRG is going to be advertised over there in this particular routing table, and how transit gateways, Aviatrix transit gateways, are going to build the IPsec connectivity to the WAN router is through this routing table. So let me tell you what's going to happen. Let's say the on-prem environment, these routes are, for example, if this is 192.168 something, and then your transit VCN is, let's say, 10.0. 10.0 DRG knows, DRG advertise using the BGP to the WAN router. The WAN router knows how to get to it. The other direction is a concern right now. The WAN router advertises its 192.168 interface to the DRG. DRG knows it. And now, by the creation of this routing table, and then association of this routing table to the DRG is going to create the routes over here in this particular routing table. Now, what's going to happen, we are going to utilize the transit gateways ETH0, and ETH0 with the quad 0 pointing towards the ETH0 means we are going to utilize this particular routing table where we know how to get to the 192.168. That's all we need. Once we have the connectivity from the transit gateway to 192.168, basically we can now create our overlay, the Aviatrix overlay. So what's going to happen at this point, we are going to create the IPsec connection with the on-prem world like this. As you can see, if the throughput is going to be limited, right, with only 2 connections going from on-prem to the cloud, If you need more throughput, either you increase the number of these connections, or you can utilize a different technique, which I'm going to talk about it. All right, so let's take a look at the end-to-end communication, the traffic flow. And for example, if the route, which maybe over here some RFC 1918 and non-RFC 1918 routes being advertised from the on-prem over to the cloud world, then these routes being advertised using the BGP, and it's going to utilize the overlays over here. And then transit gateway are going to receive all those routes. And then here at this point, you're using the BGP at this point, right? And this is an IPsec connection. Now, transit gateways has routes. Controller are going to pull those routes and going to program the spoke gateways. And then if these are non-RFC 1918 routes too, the controller is going to go into the VCN routing tables and going to program the non-RFC 1918 routes in there as well to have the end-to-end connectivity. That is how you are going to achieve this standard IPsec connectivity. So what about if you want to have the high performance encryption in this scenario? I'm going to utilize the same architecture. What I'm going to do, I'm going to deploy the Aviatrix Edge at the on-prem, or maybe it's going to be in the colo. It doesn't matter. So Aviatrix Secure Edge will be deployed over here. And then instead of terminating the connections to the WAN router, what we are going to do, we are going to terminate these connections to the edge. Like this. And then there will be multiple connections. So how many tunnels? Basically, the number of tunnels is going to depend on the size of the transit gateways which you are going to use. So if you have this fast connect, which is 10 gig or so, then you can definitely achieve that. Now, another question is, I am in a multi-cloud environment, and I need to build the connectivity to maybe AWS, GCP, Azure, Alibaba, any other cloud too. You can utilize the same Aviatrix Secure Edge and then build basically the same kind of IPsec tunnels, which is the high performance encryption tunnels, with another transit over here too. All these tunnels which you are seeing over here, we are utilizing the private IPs, and you are getting a very high throughput in this scenario. And all these tunnels are self-managed, so the customer does not have to manage any of these tunnels. Control plane is the same Aviatrix controller, which is taking care of all this setup over here. Routes between the Aviatrix transit and then the edge, depending on the version of the Aviatrix Secure Edge. If it's version 1.0, then you will be doing, or you will be receiving the routes using the BGP. If it's version 2, then it will be SD routing. So software-defined routing all the way from the cloud to on-prem, and then you will receive the routes to the transit, and transit is going to, and then from the controller is going to program the routes in the spoke gateways. Now let's talk about the public circuits here. Public circuit in this scenario is going to be internet. And then there are two different architectures over here as well. Right? So the first architecture is using the standard encryption. I'm going to draw the same architecture one more time. So these are spoke. All right, so if you take a look at this architecture I just drew over here on top, it's all Aviatrix Transit, and at the bottom you can see you have either the colo or the data center, and then over there the WAN router is going to have the internet connectivity, and then this internet connectivity is going to connect your cloud transit VCN using the IGW. All you need to build the IPsec connectivity from the Aviatrix Transit to the on-prem, you just need the public IPs at this point. Since you have the public IPs on Aviatrix Transit gateways, HA, and then the primary one, you need the public IP on the WAN router as well. This WAN router could be 2 WAN routers for the simplicity's sake. I'm just drawing one, and typically they are 2 for redundancy purposes. So you build the standard IPsec connectivity. Now the routes advertised from on-prem are going to reach WAN router, and then the WAN router is going to advertise these routes using the BGP running over IPsec to the Aviatrix transit. Once the routes received by the Aviatrix transit, the controller is going to do its magic and propagates the routes into the spokes and then the VCNs, spoke VCNs routing tables as well. And that's how you can get the end-to-end connectivity. The next one is, how about you still wanted to use the public circuits, but at this point you wanted to have the high performance encryption. So similar concept that we discussed over here in the private circuits, you need the Aviatrix secure edge over here. And then instead of terminating the IPsec connections on the WAN router, at this point you will be terminating these connections straight over to the Aviatrix secure edge. The performance of these links depends on the internet circuit, basically how big is the internet circuit, what kind of throughput you have, and then the number of tunnels, again depending on the size of the transit gateway. One good thing about this architecture is no need to manage these tunnels. These are all self-managed tunnels, and then it can provide you the high performance throughput, again depending on the size of your internet pipe. One thing over here in this architecture is you want to make sure that the public netted IPs are required on the Aviatrix secure edge. All right, so that's all I have for OCI hybrid cloud connectivity. And in the next session, I'll be discussing about the Azure hybrid cloud connectivity. Thank you very much for watching.